Hey guys, so happy Memorial Day. It's Memorial Day. It's a beautiful day out. Got a great background here. You know, Memorial Day is a huge day for everyone that sacrificed for our country, including these guys. If you don't know this statue right here, it's from the famous Battle of Iwo Jima in World War II. Pretty amazing story if you ever read about that, the flag being raised up on the mountain at Iwo Jima. But anyways, we have lesson 24, so we're going to talk about fractional exponents. And to start things off, I have two examples for you. I have 16 to the 1/2 and 81 to the 1/2. So we're raising these to fractional exponents. What I'd like you to do is take your calculator and try raising 16 to the 1/2 and 81 to the 1/2 and see what you get. If you want to pause the video real quick, do that, and then come back. I'm going to show it to you on my calculator. All right, so on the calculator, the easiest way to put this in, if you want to do 16 to the 1/2, you want to type in 16, all right, raised to remember the caret symbol is your exponent button. Now remember the fraction button. I don't know if you guys remember that or not, but if you go to alpha and then F1, or the y equals button, and choose number 1, it puts a fraction up there for you. So I want to raise 16 to the 1/2 power, and I get 4. So what you should have found is that this comes out to 4, and this comes out to 9. So those numbers should mean something to you because they are the square roots of each of those. So what you should have found out is that if you raise a number to the 1/2, it's the same as square rooting the number. That's how fractional exponents work. They are the same as taking in this case, the square root, but other roots of the numbers. I'm going to show you a couple more of those in just a second, but just general summary here. Any number raised to the 1/2 is the same as square rooting the number. So raising to the 1/2 is the same as the square root. So 16 to the 1/2 is the same as the square root of 16. 81 to the 1/2 is the same as the square root of 81. All right, I'm going to erase and show you some more here. So now what I'm going to do is raise some numbers to the 1/3 power to show you what that looks like. So let's take, for example, 8 and raise it to the 1/3. Now, if you did that on your calculator, the same way we did all the other ones, typed in 8 raised to use the fraction button, 1/3, you would see that the result is 2. So what has happened here? Well, keep in mind that 2 times 2 times 2 is 8. So what we've just done is we've cube rooted the 8. Raising to the 1/3 is the same as cube rooting. So 8 to the 1/3 is the same as taking the cube root of 8. That little 3 out there means we're taking the third root of 8. And of course the result is 2. So how do you do a cube root on your calculator? Just in case you were wondering, if you take your calculator, obviously we could take 8 and raise it to the 1/3 power and get 2. But how do you type in the cube root of 8? You can do that by going to the math menu, hit math, and if you go down to number 4 right there, that is your cube root button right there, number 4. Hit enter, and then type in 8 right there, and you'll see the cube root of 8 is 2. So raising a number to the 1/3 power is the same as cube rooting it. So for example, if you wanted to do 27 to the 1/3 power, that'd be the same as taking the cube root of 27. The cube root of 27, what number times itself 3 times gives you 27? It's going to be 3. 3 times 3 times 3 is 27. You can confirm that on your calculator if you need to. So raising to the 1/3 power means the same as taking the cube root of the number. All right? Let me show you raising to the 1/4 power. All right, so let's look at a number raised to the 1/4 power. We have 81 raised to the 1/4. So we've discovered that raising a number to the 1/2 means you square root it. Raising it to the 1/3 means you cube root it. So now we're going to raise to the 1/4, and that, by logical conclusion, means we're going to 4th root it, which means we're going to take the 4th root of that number. So we are going to take the 4th root of 81, which means we're going to find a number that multiplied by itself 4 times gives me 81. That's what it means to 4th root a number. Now, if you can't do that in your head, you can certainly do that right on your calculator using the 4th root button. Now, you could take 81 and raise it to the 1/4, and that's fine too, but I want to make sure you guys understand what these fractional exponents mean, not just use a calculator. So let me show you what the 4th root of 81 would look like on the calculator. You're going to hit the math button again, and instead of choosing number 4, which was the cube root of a number, you're going to choose number 5, which has an X out in front of the root. If you hit enter, it's probably going to say answer up there in the corner. That's what it automatically puts your previous answer in there. That's not what we want. We don't want the answer right there. We want to just delete that out right there. We want to put in what root we want to take. We want to take the 4th root of, go into the radical here and put in 81. So we're taking the 4th root of 81, and we hit enter, and the result is 3. And the reason the result's 3 is because 3 times 3 times 3 times 3 is 81. That's what it means to raise a number to the 1/4 power. So we've seen that raising to the 1/2 is square rooting, raising to the 1/3 is cube rooting, raising to the 4th is 4th rooting. You could keep going with this. You could do the 5th power, the 6th power, all that stuff. You don't usually see much higher than that when you get into pre-calc, so I'm going to stop at the 4th root. But now I want to show you what happens when we change this denominator right here to a number that's different than a 1. All right, so I have 3 examples up here. Let's start with the first one. It's 4 raised to the 3/2 this time, instead of the 1/2 power. We're going to use our properties of exponents to help us simplify this a little bit. What we're going to do is we're going to change this 4 to the 3/2 to 4 to the 1/2 raised to the 3rd power. Now, why does that work? Well, remember, when you raise a power to a power, your rule is you multiply. And when you multiply a 1/2 times 3, you get 3/2. That's going to keep this easier for us because we know what 4 to the 1/2 is. Raising something to the 1/2 is the same as square rooting it. So the square root of 4 is 2, and it's still being raised to the 3rd power, and 2 to the 3rd power, 2 times 2 times 2, is 8. So our final answer is 8. Now, you could very easily take your calculator and type in 4 raised to the, here's my fraction button, 3/2, and get an answer of 8. There's nothing wrong with that. I just want to make sure that you guys understand the concept of how these fractional exponents work, because it's going to be useful when we start solving exponential equations that have fractions in them. So you want to make sure you understand that raising to the 3/2 means raising to the 1/2 and then also raising to the 3rd power as well. All right, so let's do the next one. 9 to the 5/2. That's the same as 9 to the 1/2 being raised to the 5th power. So again, I'm changing it to something we know. So 9 to the 1/2 is 3, because raising something to the 1/2 means you square root it. So the square root of 9 is 3. So we're taking 3 and raising it to the 5th power. 3 times 3 times 3 times 3 times 3, 5 times. You can do that on the calculator if you need to. 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 one more time is 243. So 243 would be your answer there. Now this last one, I'm combining negative exponents with fractional exponents to kind of merge this stuff all together. So we have 16 to the negative 3/4. All right, let's start by reminding ourselves that raising something to a negative exponent is going to change this to a fraction. So this is going to become 1 over 16 to the positive 3/4. That's what negative exponents do. They become positive and they get sent to the denominator. So now I just got to figure out what 16 to the 3/4 is. I'm just going to do that work off to the side here. To do that, I'm going to change it to 16 to the 1/4 raised to the third, because I know what to do with 16 to the 1/4. Raising something to the 1/4 means you take the fourth root of that number. The fourth root of 16 is the number multiplied by itself 4 times. It gives me 16. So 2 times 2 times 2 times 2 is the winner. So this 16 to the 1/4 is actually 2. So this is 2 to the third power, because this turned into a 2, which is going to give me 8. So this turned into an 8. So my final answer is 1/8. All right. Now you could also do that on the calculator, like I said before. So let's just talk about this real quick, make sure we understand. So if I take 16 and I raise it to the, use my fraction button, I need to put a negative out in front, so I just arrowed over, put a negative on there. So 16 raised to the negative 3/4. So there's what I got, 16 raised to the negative 3/4. The calculator is going to give me the decimal version of that answer, which is 0.125. I like the fraction answer better, but the 0.125 is not wrong. But if you wanted to know what that was as a fraction, there's also this fraction button on the calculator. I think we talked about this in class. If you hit the math button and you select number 1, which says frac, which is short for fraction, and it puts that in there, and then you hit enter, and it does switch your answer to 1/8. So 0.125 is an okay answer for this question. It's just 1/8 is the answer we get if we do it manually without the calculator helping us. All right, so when you do your homework, I'm asking that you don't just type these into the calculator and hit enter. I want you to understand the concept of fractional exponents, use those concepts to evaluate these, try to do it the best you can without using the calculator. Now, if you get stuck and you get to the point where you don't know what the fourth root of 16 is off the top of your head and you need to put that in the calculator, I'm okay with that, but just make sure you understand how these fractional exponents work, because they're going to be very, very useful when we solve exponential equations here very soon. All right? Happy Memorial Day. Iwo Jima.